There are three long stretches with no vowels in word 3, EYXDO, in word 7, KIGXG, and in word 8, YIWZ. This suggests that I and or X might be a vowel. Both have lots of different contacts, but it is extremely unlikely that X represents a vowel, because then word 11 would start with 3 vowels and end with a vowel. This is rare in English. The only example I could find is Ouija. SQXMV cannot be AIOLI because of the repeated I. So I is probably a vowel and X is a consonant. Let's take a second guess at distinguishing vowels from consonants. In the ciphertext, there are 5 pairs of tentative vowels: VL, VS, VQ, QL, and SQ. Pairs of vowels are not common in English, so it is likely that either V or Q is really a consonant. It is probably not Q, because then word 10 would end with 5 consonants. The only such 6-letter word I know is ANCTS. Let's make I a vowel, make V and X consonants, and see where we stand. This looks right. From word 3 we can now identify D as a vowel, and from word 11 it is probable that M is a vowel. All 6 of the vowels have now been found, so every other letter must be a consonant. Here is the complete breakdown of consonants and vowels. The second phase is identifying individual letters. The following letter contact table shows the contact characteristics for the letters of the English alphabet. A different language would have different characteristics. For example, the letters M, V and Z are most often both preceded and followed by vowels, while the letter N is usually preceded by a vowel but followed by a consonant. I compiled this table using the English language corpus of the Gutenberg project. There is one good candidate for plain text H in the cryptogram, namely ciphertext U. However, U appears twice in the bigram US at the end of words, so is unlikely. There are 2 strong candidates for N in the cryptogram, namely ciphertext E and O. Both E and O represent consonants that are always preceded by vowels and followed by consonants. However, O is the stronger choice because it has higher frequency and because it precedes 2 known consonants in the word slorus. In English, 3 consonant combinations often begin with N, such as NST and NTH. It is more likely that O represents N. This yields. It is now feasible to try to find possible words matching some of these patterns. I found 67 words matching Zlorus X circle N XX circle. Of these, 32 ended in E and 27 ended in Y. I found 37 words matching SQXMV, circle circle X circle X, and not containing N. Of these, 15 began with Y, but only 1 began with E. It is therefore most likely that ciphertext S represents plaintext Y. This gives us the ciphertext words IVQOR and ZLORUS both contain the bigram OR. Let's try to identify that. Knowing that IVQOR circle X circle N X does not contain a Y leaves only 24 likely words. Of these, 12 end in G and 8 end in S. Hence, ciphertext OR is probably either NG or NS. The number of likely plaintext words for ZLORUS X circle NXXY is now down to 26. Among these, the 4th letter is G 8 times, T 6 times, but S only 1 time. The most likely choice for ciphertext OR is thus plaintext NG. We now have There are 8 possibilities for the first word, ruleys. These contain only 6 possibilities for the bigram ul. For each of these choices, let's look at the possibilities for the word zlorus. The choice zlorus equals jungly can be ruled out immediately because ksyiwz would then have the form xy x circle xj. There is no such word in English. This means that ruleys represents grumpy and zlorus represents hungry. Filling in these new letters gives. The rest of the letters can be filled in by sight. It is now obvious that the second word is pudgy and the third word is bumpkin, which makes the 8th word bypath, and so forth. The completed cryptogram reads, Grumpy Pudgy Bumpkin clumsily stumbled along back-country bypath, hungry unshod yokel. Simple substitution is rated 1. When the letter frequencies and contact frequencies have been intentionally distorted, as in this example, the rating can go up to 2 or possibly 3. This makes a good puzzle, but is useless for general communications.